To get started with sketching in Fusion 360, I want to set the stage for why sketching is important, as well as explain some of the best approaches for creating sketches. To begin, I'd like to discuss the role of sketching in CAD. Sketches are the foundation for creating some of the most important three-dimensional features. Sketches are typically comprised of two-dimensional sketch entities, created on either a plane or an existing flat face of a part. Then the user creates sketch elements by either drawing them or using existing geometry. Once a sketch is created, it can be used as a profile to create a 3D feature. These profiles are pulled outward, either linearly or along a curved path, which creates unique, solid geometry based on the sketch. Sketches are extremely powerful when created from existing geometry. By selecting existing vertices, edges, and faces in the model, the geometry can be copied and adjusted in the sketch. For instance, the Offset tool can copy the outer edges of a face and simultaneously reduce or expand the sketch profile. In this case, it was used to quickly create a cutout inside the part by copying the outer edges. These sketch entities also remain linked back to the original geometry, which means that if the original geometry is modified, the sketch will update as well. This greatly aids in keeping the model up to date when changes are made. Now that you're a bit more familiar with sketching, I'll demonstrate some of these aspects by creating some sketches and some 3D features from those sketches. Here, I have a blank Fusion 360 document. To begin creating a model, I can start sketching on any of the three default planes. The view automatically rotates to look directly at the sketch plane, where I can begin adding 2D sketch entities. For instance, I can draw a hexagon. I want to make a quick note here that drawing sketch entities centered on the origin is often considered best practice in the software and can provide a number of advantages later on in the modeling process. Now that the hexagon is drawn, I can continue adding other sketch elements, such as a circle. To start the Circle command, I'll right-click to access the Marking menu, which is a quick access group of commands available at any time. I'll move down to the Sketch Tools and click on the Circle command. I'll draw this circle centered on the origin once again. These sketch entities are controlled in a couple of ways, using constraints and dimensions to relate the geometry and set the sizing. It's considered best practice to apply constraints first, which are rules applied to relate the geometry in the model. For instance, I can select the horizontal-vertical constraint, and then I'll select this line at the top to make it horizontal. Now this line will remain horizontal, even when I try to move the hexagon by dragging one of the corners. Dimensions can also be applied to set the sizing of sketch elements. For instance, I can specify how large the diameter of the circle is, as well as defining the length of a side of the hexagon. Now the sketch is more defined and can be controlled by adjusting these constraints and dimensions. I'll click Stop Sketch to exit the sketch environment. Now this sketch can be used to create a 3D feature. This sketch has two enclosed profiles, which I can pull outward by using the Press Pull command. Notice the two profiles I can select to create the 3D feature, either the inside of the circle or the profile between the circle and the hexagon. Because Fusion 360 allows you to select individual profiles in a sketch, you have much more control over how the sketch creates 3D features. I'll select this profile, then pull it out into a 3D feature, and click to finish the Press Pull command. Now that the 3D feature is created, I'd like to showcase how important the sketch is when controlling the 3D geometry in parametric modeling. If I edit the sketch and change one of the dimensions, such as the diameter of the circle, the 3D feature automatically updates and reflects the change made in the sketch. This 3D geometry will always be linked back to the sketch, allowing for a number of changes to be made at the sketch level. The first step to starting a sketch is selecting the 2D plane or face to draw the sketch. In order to start a sketch on a face, there must already be existing 3D geometry. which I will demonstrate a bit later in this lesson. However, I'm currently working from a blank document, so I'll select one of the 3 origin planes to create my sketch. One way of beginning a new sketch in a blank document is by selecting the Create Sketch tool. This is found in 2 locations: at the top of the Sketch panel and in the right-click menu under Sketch. Once enabled, the 3 default planes appear in the middle of the canvas, which can be selected to create a new sketch. At this point, I'd like to emphasize the importance of choosing a specific sketch plane. The plane you choose will determine which way your 3D features can be created. For instance, if I drew a sketch on this plane here, which is known as the XZ plane, the 3D features would extend outward away from the plane along this green Y-axis. For now, I'll choose this plane, and the view automatically rotates to look directly at the sketch plane. I'll quickly draw a sketch entity using the Center Rectangle tool and start the sketch at the origin. I'll exit this sketch for now by clicking Stop Sketch. If I show the default planes by turning on the Origin folder in the browser, notice how the rectangle is oriented in the model. It lays flat the same way as the XZ plane, which could extend and create a 3D feature in the direction of the green Y-axis. Additionally, the sketch is stored in the browser, as well as the parametric timeline. I'll hide this sketch for now. Creating a sketch can also be done by clicking in the reverse order. I could first click on one of the planes and select Create Sketch from the drop-down menu or the right-click menu. Now, I'll switch over to another design to demonstrate how to create a new sketch on an existing face of a model. Before I create a sketch on any of these flat faces, I want to quickly demonstrate how construction planes can be used to create a sketch. I'll turn on the construction folder in the browser, and I can see a couple construction planes appear in the model. These types of planes can be used to create sketches at unique angles. If I turn on the sketches from the browser, notice how the ellipse and the rectangle align with each respective plane. These sketches intersect the model, but are not bound by any geometry. As seen here, any sketch entity can be drawn anywhere in the sketch plane, whether it intersects the model or not. To sketch on either of the construction planes, simply select the plane and then click Create Sketch. As mentioned before, this can be done in the reverse order as well. Now I'll create a sketch on an existing face. For instance, I could use this face here. To start the sketch, I can select the face, then click Create Sketch. Notice how I can't see the face I'm sketching on. This is because the view oriented in a way that shows material above the sketch plane. To temporarily hide this material above the sketch plane, I can use the Slice tool by selecting it in the Sketch palette. Now, I can sketch on this face and clearly see the sketch entity. I'll make sure the sketch is showing, then draw a simple center circle, and stop the sketch. I can see that the circle lies on this face, which is clearly seen as I rotate the model. Creating a sketch is as simple as selecting a default plane, construction plane, or existing flat face, and then selecting Create Sketch. From here, the sketch can be drawn anywhere on the plane or face. Now that you've seen how 2D sketches drive 3D features, I'll switch over to another design to show you how a single sketch can be used to create multiple 3D features using different profiles. The sketch shown here has a few circular profiles and a tab extending at the top, along with a line on the left that will be used to create a revolve feature. This will be the first 3D feature I'll create from this sketch, so I'll go ahead and enable the command from the Create drop-down menu. And I can begin selecting closed profiles within the sketch. I can select as many as I need until I get the correct collective profile. As a side note, it's typically easiest to select all of your profiles from the top of the screen down to the bottom. I'll quickly finish this 3D feature by selecting the axis of revolution, as well as change a few parameters for the feature. Now that I've created the first feature, I can create a second feature from the same sketch. To make this easier, I'll hide all of the bodies in the model, and I'll make sure the original sketch is visible. I'll use the press-pull command to create the second feature, which I can access directly from the marking menu. Then select the profiles I'd like to pull upward, turn visibility of the bodies back on, adjust a few parameters, and click OK. Now both 3D features are included in the model, driven by a single sketch. Before wrapping up, I'd like to show you how to quickly create a sketch using existing geometry. I'll create a sketch on this top face that will cut back down through the part. First, I'll make sure the sketches are displayed. I'll create a new sketch on this face, and to create the sketch, I'll offset the outer edges 5 mm inward. Now, I'll use the press-pull command to cut down into the part and adjust a few parameters for the feature. I was able to quickly create a new sketch and a new feature using existing geometry. This can be done by creating a new sketch on any flat face in the part. As you can see, sketches are powerful and allow customized 2D geometry to drive 3D features. Since sketches are the building blocks for many 3D features, the model geometry can be modified parametrically by making adjustments to the sketches. However, in order to make adjustments to a sketch, it must first be identified in the model, and then it can be edited. This bike pump is made of a number of sketches and 3D features, as you can see by the number of items in the timeline. If I want to make a modification and extend the pump arms, I'll need to identify which sketch created the feature, and then edit that sketch to make the change. Before I identify which sketch I need to edit to extend the arms, I want to mention where sketches are located in Fusion 360. There are two main locations. First, sketches can be found here in the browser. All sketches used in the model are stored in this folder, listed in the order they were created. Second, sketches are located in the parametric timeline at the bottom. The sketches are also placed in the order in which they were created, unless they were purposely repositioned. Now, I'm ready to locate and edit the correct sketch. In this model, the sketch arm can be located fairly easily in the browser. However, when creating a new model, the sketches aren't named in this manner and can be more difficult to locate. One method for locating the sketch is stepping through the parametric timeline and seeing when the arm was created. This will help pinpoint which sketch created that feature. To step through the timeline, I'll click the arrow on the left to roll the timeline all the way to the beginning, which suppresses all features in the model. Next, I'll start clicking the smaller right arrow, which allows me to move through the timeline one feature at a time. I'll continue clicking until the arm appears. Now that I can see the arm as a 3D feature, I know the sketch must be present in the timeline. Oftentimes, the sketch is listed just before the feature, which you can see when I hover over it. Now that I've identified the sketch, I can select it in the timeline, then right-click and select Edit Sketch. Similarly, I could right-click on the sketch in the browser and select Edit Sketch as well. Now I can make a change to the sketch. I'll change the overall length to 10 inches, and then stop the sketch. Now the arm is longer, and the entire model updated by changing one dimension. Editing sketches is extremely powerful and can drastically change the geometry of the entire model. This is because all of the features are created in order and depend on one another, so editing an initial sketch causes all of the features to adjust downstream. In order for sketches to completely maintain their shape and produce 100% predictable results, all of the sketch entities need to be fully defined using dimensions and constraints. In order for a sketch to be properly defined, there must be a strategy in place for how the entities relate to one another. This is known as the sketch's design intent. Fusion 360 does not require sketches to be fully constrained, but it's a good practice to follow. The design intent for this sketch profile is to keep all of the sketch entities symmetric about this angled construction line. This means I'll set dimensions equal to one another on either side of the line, and some sketch entities will be mirrored across the line. First, I'd like to copy these 3 circles to the other side of the angled construction line using the mirror command. I'll select all 3 circles, then add the construction line as the mirror line, and they're added to the other side. These circles aren't currently centered between the outer edges because the construction line is not centered. I'll dimension the construction line later to clean up the position. It's best practice to add constraints to a sketch before applying dimensions, forcing the sketch elements into the desired position before setting the size. First, I'll add constraints to these 3 circles. I want them to be equally spaced, so I'll add a midpoint constraint between the middle circle's center point and the horizontal construction line. Now, to center the circles between the 2 outer edges of the profile, I'll apply the midpoint constraint to the same center point and the vertical construction line. Now, I'll make all 3 circles equal size. I'll select the left and center circle and the right and center circle. Now these circles will remain centered between the outer edges, will be spaced apart evenly along the construction line, and will remain equal in size. The mirrored circles on the other side of the angled line also reflect these constraints. Now that the constraints have been added, I'll move on to adding dimensions to the sketch. I'll enable the command from the marking menu, and the first dimension I'll add is a baseline dimension used as a reference for other dimensions. I'll dimension this bottom edge as the baseline dimension, set to 100 millimeters. Notice that the line on the right turned black when the dimension was added. This is because its position is defined. However, its length still needs to be specified, which I'll set as the same length as the bottom edge to maintain symmetry. Either an equal constraint could be applied, or a dimension could be used. I'll dimension this line and create a reference to the baseline dimension by clicking on it and then hitting Enter. Next, I'll add a baseline dimension to the width of the sketch at the bottom. I'll select the 2 outer lines and enter a value of 18 millimeters. Using this as a baseline, I'll dimension the other side of the sketch and reference back to the baseline dimension. Now the 2 inner lines of the profile are shown in black since their positions are fully defined. The angled lines on the ends are still shown in blue, indicating that they are underdefined. All that's needed to define each one is to dimension either the length of the line or its angle. I'll dimension the angle from the bottom edge in this case and set it to 60 degrees. Now all these line segments at this corner are fully defined, as shown in black. I'll dimension the same angle at the top of the profile and create a reference to the first angle to maintain symmetry. To center the mirrored circles at the top, I'll dimension the angled construction line. I'll select this line in the bottom edge and set the angle to 45 degrees. At this point, most of the sketch is shown in black. However, there are a few entities shown in blue. If you are ever unsure how to finish fully defining your sketch, simply drag the blue sketch element or an endpoint to see how it's free to move. For instance, if I drag the arc, its radius is able to change. To fully define this arc, I can dimension its radius. And I'll enter a value of 30 millimeters. The only sketch entities still shown in blue are the three circles. There are 3 dimensions that need to be added to fully define them. First, I'll dimension the diameter of one circle and set it to 8 millimeters. This causes all of the circles to update to the same size. Next, I'll define the spacing between them. To do this, I can simply dimension the length of the horizontal construction line and give it a value of 30 millimeters. The final dimension will position the circles in the horizontal direction. The design intent for these circles is to keep the position of the center circle at 40% of the length of the bottom edge, which requires an equation. To create this dimension, I'll select the origin, then the vertical construction line. To create the equation, I'll reference the baseline dimension, then type times 0.4 to make it 40% of the total length, and hit enter. This dimension updates with the equation symbol and will always remain at a position 40% along the edge. Now the entire sketch is fully defined. All of the sketch entities appear in black, indicating that they are fixed in place. Based on the design intent of your sketch, making modifications to specific dimensions can be powerful and allow for instant updates. Because many of these dimensions were derived from baseline dimensions, such as the 100 millimeter dimension for the bottom edge, they can be updated and all associated dimensions will change with them. If I go ahead and change baseline dimension to 125 millimeters, the sketch updates instantly. The 2 outer edges increase in length, and the position of the circles remains at 40% of the bottom edge. At the same time, the entire sketch remained fully defined and maintains its symmetry on the other side of the construction line. Fully defining sketches in terms of the model's design intent is extremely powerful and allows you to update the model with simple changes. This will create a robust model that can be easily adjusted at any time.